Retail investors recently have been piling into AMD, and potentially for good reason. The company looks poised for a massive opportunity in AI. Check out this clip.
I think more people should be using AMD. I think not at the very large scale yet, but at the small and medium scale. And the small medium scale is pretty big, like the MI300, has 200 gigabytes of HBM. It has a huge capacity to run you could run 70 billion parameter L on one GPU. The small end is pretty stable. If you just wanted to spin up a container, spin up an inference service, download Hugging Face transformers, run it on an MI300, it'll probably just work and it'll get good performance. So that's something that you cannot say about most accelerators. And that was the thing a few years ago when I started poking into this that got me really excited about AMD, that they've made that much progress on the software stack. Even getting to that level is really hard. But you asked about what's the missing piece. I think AMD's made a lot of progress on scale out. So on running on larger scale than that, because of course, generative AI is so computationally intensive. These are the biggest models we've ever seen in the kind of history of machine learning. These are so computationally intensive. These transformers for things like GPT-4, Claude, Llama, these are just enormously computationally intensive algorithms. So you want to run them on a really large scale system. So getting scale out is maybe the next frontier for AMD. And they made a lot of progress over the last few years in inference. You can look at the MLPerf results. Their inference servers on MI300 or 325 compared to H100 or H200 are effectively neck and neck on LLM inference. So they've made a lot of progress in being able to get that scale out for inference. Training is a little bit harder though. And I actually think it's a software ecosystem challenge. So I'm going to tell like a quick anecdote about this. So back in Baidu, we built out some of the first prototypes of distributed training. We actually built the first large-scale CUDA cluster in the world. It was around 1,000 GPUs, and it was the first one ever for deep learning. So we prototyped a bunch of software on that. And one of the things we typed was distribution strategies and collectives, and then distributed training frameworks that didn't just use async, they used MPI. And the legacy of that is that some of the pieces of that, as a lot of that team actually went back and worked at NVIDIA, got integrated into Megatron. So there's now this framework that's developed by NVIDIA engineers, used to be Baidu engineers, of course, a bunch of new contributors too, but it's really a good way of doing distributed training. And it's one of the only good open source frameworks for distributed training that works at that scale. And the problem with it is that it's actually wonderful that it's open source, but because it's NVIDIA developed open source, it's not like PyTorch. It's not owned by a neutral third party. It's owned by NVIDIA, who has even if there's some altruistic nature of making things open source, there's not really a strong motivation to fix bugs or to up performance or tune performance for AMD or anyone else. So that's, I think, a big gap in the ecosystem, is that inference is probably completely fine. We have great open source frameworks like SGLang or VLLM in inference that are just fine, and they're vendor neutral. But there really isn't like a vendor neutral, good, scaled out training framework.
There's a few different layers to that clip I want to break down. Firstly, AMD's GPUs are able to run pretty large models now, 70 billion parameters on a single GPU. That's reasonably impressive. And they're expected to get a stable performance and good software performance out of that as well. Does that mean that AMD now has the potential to be the go-to choice for small and medium scale companies with small to medium scale inference workloads?
That's definitely, so the podcast that you're playing a clip from, TensorWave, they have an entirely AMD-based cloud that they're providing services for people to do small training workloads or, inference-type workloads. And they're very cost competitive with NVIDIA-based clusters. They can save people money. And because they can do that, the thing that people are worried was like, well, can I just bring my job and will it just run? Will it just work? And AMD has made a lot of progress on their ability to actually deliver that in a software ecosystem that just works. And they're really getting to the point where they're there. There might be some marginal bugs that people are running into, but I think the capability of AMD to run those small to medium-sized workloads on hardware very well within an ecosystem that works. Like their ability to do that is far beyond the public perception of their ability to do that right now, which I think is the opportunity for investors right now with AMD. Now, in the spirit of not financial advice, the challenge that AMD does have is that they're a much larger business than AMD when it comes to the scope of what it is that they do. Their exposure to the AI market is a relatively small percentage of their business compared to NVIDIA, that is just a parallel compute, accelerated compute company, essentially. They do GPUs, they do CPUs, they have all sorts of chips across all sorts of devices, and the breadth of the different number of things that they do means that the AI portion of their company is relatively small, compared to the overall company, and that that has benefits, but it also has, like, that's where there's an opportunity, but also you have to realize that there's limitations in the exposure that AMD has to that. Now, that said, there's a huge market demand for people who can compete with NVIDIA, and that demand, I think, is going to drive meaningful growth for AMD, and they really are. So there's really 3 players that have achieved software that you can really compete with NVIDIA on top of the hardware, which is, there's been lots of hardware startups. They can do interesting things with their hardware, but providing software that actually works in real world use cases is difficult. And so you've got NVIDIA has solved that. Obviously, CUDA is awesome, and this is the ecosystem that is the primary ecosystem. Google also solved that. They solved that a long time ago with TPU and their own internal framework for software that works on TPU. Now Google is actually offering TPU externally to third parties that people can buy this, and so that's going to have to involve also software support for TPU. That's going to be interesting to see how that plays out. And then AMD. So we finally see some really serious competitors that are going to be offering head-to-head products and services that can compete, at least in many ways, with what NVIDIA does.
AMD's made some big strides running large AI models on a single GPU. The next challenge for them is going to be scaling these models across many GPUs to handle massive workloads efficiently. What's holding back AMD from running huge AI models at enterprise scale, and how close are they to matching NVIDIA in large-scale inferencing?
So I think they're already there when it comes to inference. Like, they can infer the biggest models. They already have networking technology that allows these to coordinate together well enough to do, much, much larger AI models and run them at scale. And so that's what, when he talked about their performance on MLPerf and stuff like that, that AMD is a serious competitor when it comes to inference already. And the thing is that inference as a percentage of the overall data center build out that has happened is relatively small so far, but it's going to be huge. Eventually, inference is going to be probably at least as large, if not a larger overall market than the training side of things. And so if that's the case, and if AMD can be competitive with NVIDIA for inference, and they can say that, you can train on NVIDIA hardware and then you can infer on AMD hardware just fine, that's not a problem, then that should allow AMD to capture a significant market share of the overall inference market share, which is going to be a very large market share. The challenge that he was talking about there in that clip is specifically in trying to reach the largest scale for the training clusters, to be able to do with AMD hardware what Elon has done at XAI with Colossus 1 and that they're building with Colossus 2, where they can network together 1 million of these Blackwell GPUs together as a single AI brain that's all working on the same problem at the same time in a coherent and coordinated way. That is the thing that AMD hasn't achieved yet, and they're working on it. They're making really good progress. They have the hardware roadmap to be able to provide these system level racks in modular blocks that can do what the NVIDIA NVL72 GB100 clusters and then GB200s are going to be able to do. But there is questions around, is the software really going to be able to do that? Now, obviously it has to, like, AMD can't build clusters at scale that can do that without having the software that enables them to do that. Otherwise, you basically have dead hardware that you're spending a lot of money to build, a lot of CapEx that you spend, and then not really being able to sell them to customers because it can't do the thing that you built it to be able to do in the first place. So that software is going to have to be there, and very, very soon, in order for AMD to be able to continue to invest in this space.